So we've completed our version of the buffer, and we haven't really played around with it all that much. And if you do play around with it, you'll notice that it does things that aren't quite what you would expect. And we can play with this by opening inside of here. Let's see, if we go to the project, you can't see this, but there's a Scala menu. And I am going to say create Scala interpreter, which will bring up a little REPL in here. And one of the advantages of bringing up a REPL in here is that I can do things like val SLL equals a new linked list dot singly linked. Actually, no, I want the mutable SLL or SL list. Mutable SL list. Okay, so I have one of those, and it reports that it's a buffer. Well, I didn't override the toString method, so that's not kind of too surprising. And I can do this: SLL plus equals 5. Oh, I didn't give it a type. Sorry. Let's do this. Flip, copy, paste, ints. That way we can play with it. Okay. SLL plus equals 5. SLL plus equals 8. It gives us a simple way to test what we're doing. Here's the fun one though. SLL.map of underscore times 2. Okay, so I want to double all the elements. So I have the 10 and 16, but I don't have my mutable SL list anymore. Now I have an array buffer. Okay. If you want things like map and filter that create new collections to produce the collection that you've written, you have to take a few other steps. Okay, and there's a number of additional steps that we have to take in here. And so I'm going to go through in this video and show you what it is that we have to do. But I'm going to go ahead and I'm going to put it in a different class. So I'm going to make a mutable SL list 2 so that we have the original version. And I am just going to take basically pretty much everything inside of this class and copy it over. And it will be unhappy at first because I don't have everything imported. We'll import mutable, and the types here need to be mutable SL list 2. Okay, so the code's happy now. So what else do I need to do to make it so that this winds up producing this type when I do things like map and filter? Okay, in order to do that, I need to actually make this extend a few other types. And so remember, when we extend multiple types, we use the with keyword. So in addition to being a buffer, it's also going to be with a generic traversable template type. And this takes two generic types, the first of which is the type that we are working with, and the second one is our type of our collection with mutable dot. There is another trait called buffer like, and once again it actually takes our two arguments, though this time I specify the generic type as well. And you'll notice that one introduced an error because now there's a method that we have to include. And in order to make it so that it builds things properly, we bring in builder and give it the generic types. Close bracket. Okay, So now this is unhappy because it needs some method. And in particular, if you read the error messages, you can see it needs a companion and it needs a result type. So I'm going to add these into here. Override def companion, and it returns a generic companion for our mutable SL list 2. And the type here is actually going to be the companion object, which we haven't written yet, but I'll write that in just a second. So SL list 2. Let's go ahead and we'll jump to the bottom of the file and we'll add that in. Object, paste. We'll have to come back to that because it's not going to be quite happy yet. Generic companion. I did an import on that, and so now that's happy, but it's like this doesn't have the right type. We'll have to see what we do to make that. And then we also need to implement this result method, and the result will just be this. Now, it turns out that depending upon what you're doing, these will do different things. Because our mutable singly linked list is very efficient to append to, it is a good builder. Okay, that's if this wasn't a good builder, if this was not a type that was efficient to add things to one at a time, we would want to have a separate class that had the ability to build up one of these in an efficient way, and then when it was done building it, it would return the value. In this case, because the append is a very efficient method, it's order 1, we're able to do that. Okay, so we jump down here to the bottom to our object. In order to make this work the way that that it needs to be to give us kind of the integration with the stuff that we did above, this has to extend a few types. So it has to be a sequence factory on our type there. And then we need to put some things inside of it because, as you can see here, it says, hey, we can't make this because it has some abstract methods. So we need to write a new builder method, and it has a type parameter, and it returns a mutable.builder, mutable SL list 2 of A. And that's just going to be the type that we're writing here. So a new mutable SL list 2 of A. As I described earlier, the builder, our singly linked list 2 is very efficient at appending, so it works well as its own builder. By doing this here, we have the ability to, this specifies how you make a builder. The reason for this complexity is, once again, maybe you have a type that can't be built efficiently that way. So for example, single immutably linked lists, you don't append to efficiently. So you'd have to do something different there. There are other data structures where you could do things more efficiently than the way that data structure works by default, and so you want to have a separate builder, and then at the end of the process it uses that builder to basically give you a completed data structure. So you'll see that this is now happy, and if I come into here and I once again bring up an interpreter in this, now I can make a new, let's actually, val SLL is a new mutable SL list 2 of int. I forgot to put linked list dot, didn't put in the package name there. Okay, SLL plus equals 5, SLL plus equals 8, SLL dot map of underscore times 2. Now I get back, remember this still prints out as a buffer, but it's actually our type that we have here. So it is giving us the type that that we've written here, as opposed to going over to an array buffer. So this allows you to integrate things into the library. I'm a little bit unhappy that this came back as a mutable buffer. So I think, let's see, part of the issue here might be that we need an implicit conversion. This is one of those features that I try to avoid for this particular set of videos, but sometimes I can't do that. Mutable SL list 2 of whatever type A, mutable SL list 2 of A, close, equals a new generic can build from of A. Okay, and we'll see real quick, val SLL equals new linked list dot mutable SL list 2 of int SLL plus equals 5 plus equals 8. We can do that in one line, that's why it returns this. And map of underscore times 2. There we go. Okay, so this implicit conversion makes it so that it knows that the type, it actually gave us back the type that we wanted as its dynamic type, but the static type, the type that it was known as, was a more general buffer, the super type. This last line here with the implicit conversion actually makes it so that the map explicitly says, I'm giving you back this type. So there we go. That's how you can integrate things into the full library. For the most part, we're not going to deal with that. This is a complexity that if you are writing data structures that you really want to be broadly used, you will want to do this. I will note this is something that is likely to change probably in Scala 3, would be my guess, because of the changes with the Dotty compiler. But this is how it works in Scala, at least up through 2.12. So if you're having to write libraries and data structures that you want to integrate in fully with Scala, this is what you would have to do. We're not going to worry about it for most of the time.